I'm very excited to introduce you to the TinyML course kit. This is a kit that was developed in conjunction with Arduino and is widely available to everyone across the world. One of the cool things about this kit is the fact that it was designed to be extensible. In other words, while this kit serves as a basis for you to experiment with everything we teach you in this course, it's also got capabilities that allow you to expand outside of this course using the learnings that you've got from this course. Let me introduce you to the kit contents, right? So that you get familiar with what's in it. First and foremost is the Arduino Nano 33 BLE Sense. Now, this is the brains of your TinyML kit. And now you know that the Nano by now, because I've shown it to you 1,000 times in my slides. So hopefully you're really excited to hold it in your hand. And this is a small microcontroller development board, which has got all the elements of a modern embedded computing system in it. For example, it's got a rich number of sensors. It's got a microphone, an IMU, a light sensor, and a proximity sensor. It's also got actuators in the form of RGB LED indicators that allow you to understand, if the machine is trying to communicate something to you according, to what code you have written. And it's also got a communication hardware module that is on board, specifically in the form of Bluetooth, which allows you to transmit data without having a cable tethered to it, which makes it quite exciting. And it's something that we'll be using for the magic wand example. We've actually interfaced that Nano with a camera module like this one over here. And the OV7675 camera module is a low voltage color CMOS image sensor. It's got a couple of breakout pins on it. Now, this camera module outputs a resolution of about 0.3 megapixels, which is sufficient for the kind of things that we'll be doing in our TinyML use cases. Because it's got so many pins, one of the problems that we often tend to have is that these pins actually are put incorrectly, and this leads to a lot of problem with debugging. In order to get rid of that problem and make things easier, the TinyML Shield was designed. The TinyML Shield, as over here, is basically a daughter PCB board that's designed to have many I/O pins that will allow you to easily interface the Nano 33 and the camera module together. But not only that, it's got a lot of flexibility built into it. Specifically, if you look at the bottom of the board where your Nano 33 is going to be easily plugged in. Now, if you look at the top of the board, that's where the pins of the OV7675 camera module get plugged in. So you don't have to worry about any wires in order to connect those pins, as you're starting out with the camera module, no mistakes, and you'll be able to get started immediately. On the right-hand side of the board, you've got standard Grove connectors that allow you to have serial communication with other types of sensors. And on the left-hand side of the board, you also have another set of Grove connectors that allow you to break out with analog or digital general purpose I/O or GPIO pins. You'll be able to use these GPIO pins to interface with single digital channels, say for LEDs, buzzers, buttons, and so forth, or with analog channels for potentiometers, light, and microphone type of sensors. Here are some examples of sensors that you might be able to interface with. For example, you might be able to interface with a thermocouple sensor or an optical rotary encoder if you're using it for some kind of mechanical or robot system. And now these are sensors that you'll have to buy separately, but they come with a cable that can be easily plugged into the sides of the board. So therefore, the TinyML Shield allows you to explore much more than what we do in this particular class. Finally, at the bottom right, you'll see that there's on the left-hand side, you'll see that there's programmable button. And then we also have a screw terminal for external power on the right. The screw terminal allows you to easily and safely connect a battery to make the system fully independent. In other words, it can be completely disconnected from all the wires and be able to interact with the device while it's using battery power. And so this way you can hold the device up and take a selfie just like that. And with that said, I hope you're excited about the TinyML kit. The designers spend a lot of time thinking about, what is the most easiest and convenient way of packaging up materials for you, so you can focus on what really matters and not get distracted by the physical components and the mechanics that are needed to get this whole thing running. So let's start using this kit now.